Welcome to our video lesson about Boyle's Law. Before we proceed to our lesson, let me introduce to you Robert Boyle.
Robert Boyle first stated in the 16th century that the relationship between volume and pressure at a constant temperature is inversely proportional.
It means that with a fixed amount of gas, the volume decreases as pressure increases, and vice versa at a constant temperature. With the behavior of gases, the inverse relationship between volume and pressure will be justified only if the temperature of the gas is not changing. Similarly, that is what you have observed in your activity with the syringe and the balloon. This picture also shows how the pressure changes with a change in volume. Imagine a syringe filled with gas particles. When you push the plunger, the volume of a free space inside the syringe decreases. Since there is a decrease in the free space inside, the gas particles will collide more often with the walls of the syringe, making the pressure inside increases. In contrast to that, as the plunger is pulled, the free space inside, which refers to the volume, decreases. With that greater area for the gas particles to move, there is less collision with the walls of the syringe, causing the pressure to decrease. Mathematically, the inverse relationship between pressure and volume is expressed through this equation. Thus, arising with the Boyle's law formula, P1 V1 equals P2 V2, where P1 is the initial pressure, P2 as the final pressure, V1 as the initial volume, and V2 as the final volume. As what you've noticed, there are initial and final variables because pressure and volume may change over time in a certain situation. Let us now proceed to the application of Boyle's law formula in a given problem. A scuba diver needs a diving tank in order to provide breathing gas while he is underwater. How much pressure is needed for 6 liters of gas at 1.01 atmospheric pressure to be compressed in a 3-liter cylinder? Okay, so this time, we're going to solve a problem applying the Boyle's law formula.
First, we need to identify all the givens from the problem. So we have there 6 liters of gas at 1.01 atmospheric pressure to be compressed in a 3.00-liter cylinder. That means that 6.00 liters is the initial volume. Since 6.00 liters of gas is at 1.01 atmospheric pressure, then that's supposed to be the initial pressure. And the gas must be compressed into 3.00 liters, making it the final volume. Thus, we are looking for the final pressure. So what we're going to compute from this problem is the final pressure. We have the Boyle's law formula in which P1 times V1 is equal to P2 times V2. But we need to derive first the formula in order for P2 to remain in one side, since it is the variable that we're looking for. So for P2 to remain in one side, we need to cancel or divide both sides by V2 so that V2 will be cancelled. Therefore, our final formula is that P2 is equal to P1 times V1 over V2.
Alright, now you have your first move or your first step. Any questions so far? Okay, before we proceed to the next step, Be familiarized with the first step that we have conducted. Now let us continue.
Remembering the derived formula, we have P2 is equal to P1 times V1 over V2. Now we're going to use the formula and substitute the given from the problem. We have there our P1, which is 1.01 ATM, multiplied by our V1, which is 6.00 liters, divided by the final volume, which is 3.00 liters. Thus, our final pressure will be 2.02 ATM. Why is the unit ATM? Because what is asked is pressure, and liters will be cancelled with the division process.
Now we have it.
Applying the significant figures, our final answer will still be 2.02 since all of the given has 3 significant figures, meaning our final answer must also have 3 significant figures. And as what you've noticed, from having 1.01 ATM from the initial pressure, the pressure increases into 2.02 ATM, in which the volume decreases from 6 liters to 3 liters. And that shows the inverse relationship between pressure and volume, that as the volume decreases, the pressure increases.
Okay, for you to master our lesson, let us have another example.
This time, instead of pressure, we'll be looking for the volume. So we have there 40.0 liters at 7 ATM, and makes that the initial volume and the initial pressure. So what is asked is the volume that will it occupy at 5 ATM. Therefore, we are looking for the final volume, and this makes 5 ATM as the final pressure. As we've done a while ago, we have to derive again the formula P1 times V1 is equal to P2 times V2. This time, since we're looking for V2, we will going to divide both sides by P2 so that it will be cancelled, and V2 is the only variable will remain in one side. Therefore, our final formula will be V2 is equal to P1 times V1 over P2.
Okay, remember the derived formula before we proceed to the next step.
Again, our derived formula a while ago from the first step is that V2 is equal to P1 times V1 over V2. Now, let us substitute all the given in our derived formula. So we have here the initial pressure, which is 7.00 ATM, to be multiplied to the initial volume, which is 40.0 liters, and will be divided by our final pressure, which is 5.00 ATM. So what will be the result after the multiplication and division? So the final answer will be 56 liters. Looking at our significant figures, the given has 3 significant figures. We do not have the least figs here since all the variables have the same significant figures. Thus, what are we going to follow is that using 3 significant figures. Since we only have 2 and 56, we'll just simply add 0.0 so that we'll have 3 significant figures. So at 5 APM, the volume will be 56.0 liters. Now looking at the result, comparing the pressure, the initial to final, the pressure decreases, which means that the volume must increase. That's why from being 40 liters, the volume of the gas increased to 56 liters. And that shows again the inverse relationship between pressure and volume. Lastly, I'm going to show you on how to derive the formula looking for the initial pressure and the initial volume. The same thing as what we've done a while ago, since we have P1 times V1 is equal to P2 times V2. If we're looking for P1, we'll simply divide both sides by V1 so that P1 will remain on one side and V1 will be cancelled. Therefore, if we're looking for initial pressure, the final formula will be P2 times V2 over V1. Same thing with the initial volume. We have P1 V1 times P2 V2. Since we're looking for V1, we'll divide both sides by P1. Thus P1 will be cancelled and V1 will be equal to P2 times V2 over V1.
Okay, there you have it. I hope you learned something today. And if you have any question for this application or for this formula, you can chat your question below and you can comment in our video. For your exercise, I'll be giving you 2-word problems to be answered applying Boyle's law formula. Answers with complete solution will be uploaded in your Google Classroom. Thank you. Have a nice day. And that is our lesson for today. See you again next time for the new episodes of learning to the YouTube channel, which provides you not only basic concepts but also complex lesson. I am your Sir AJ.
And I am your Mom Chin.
This is Super Science. Bye!